So let's hurry up. First of all, some words about me. I'm Gerrit Grunwald, working for Karakun Engineering in Switzerland, mainly doing UI work, mainly front-end all the time, and preferably Java or JavaFX. So let's go back to 2012. In 2012, I don't know if you remember that, but Google claimed the desktop is dead. The future of applications is the web. Right, we got the first Chromebooks and all that, so everybody was woohoo, web forever. 7 years later, when I take a look at my application folder, it should look like this, right? Just browsers, because everything desktop is running in the web now. Well, if I take a look in my application folder, it looks like this. Lots of applications. Native ones. There might be 1 or 2 Electron apps, but in the end, this is also a native frame running on my machine. So, what does that mean? Right? That means it seems desktop is not dead yet. That's for sure. I'm pretty sure. So, who is using native apps here? So, who's only working on the web? Everything, nothing else. Chromebook. Okay, that's what I thought. So then what about Java in that environment, right? So let's shortly take a look at the available toolkits, and they are still available. So AWT, someone working with AWT still? No? Good. It's from 1995, it's a cross-platform toolkit, platform dependent, because it's bound to native controls, it interfaces to native controls. SWT, who uses Eclipse? A few people, okay. So who does SWT rich client frameworks or something? Rich client applications on the Eclipse framework? 1, okay. So it's also quite old, still works. It's nearly the same cross-platform, it's platform dependent, it's also a wrapper around native controls, which makes it really hard to style stuff. If you ever try to style a SWT application to make it look like a modern application, it's not really nice. Then we have Java Swing. Who is using Java Swing here in the audience? Still a few. And still actively developing Swing? 1, 2, 3? A few, okay. So that was the official successor to AWT. It came with Java 1.2 since 1998. It's cross-platform, that was platform independent, it introduced look and feels. Did someone ever wrote a look and feel for Swing here in the room? Oh yeah, that's nice. I tried that once and I failed. It's really not that easy. It's possible, and yeah, but not that easy. And it emulates the appearance of native controls. Well, then there was this thing called JavaFX script, which should be the successor to Swing, but it never really took off because that was a completely different language. It was a scripting language, and it seemed like Java developers really didn't like it. So it came with Java 1.6 in 2008. Again, cross-platform, platform independent, no Java syntax. And it was a declarative way to describe UIs, and it is based on F3. Does someone know F3 or remember it? Yay, 1. Which was fine. I also remember when it came out, and then Oracle, or at that time it was Sun, decided to just let's make something new out of it, like JavaFX script. Well, it never really took off. Still works. Then they came up with JavaFX. Does someone do JavaFX here in the room? Oh, a few. Okay. This is the official successor to Swing, and it's since Java 7. It was never part of the JDK. It was just delivered with the JDK, right? Which is really a difference. That's the reason why Swing is still in there. JavaFX is not. It's cross-platform, platform independent. In principle, that was a port from JavaFX script to Java. That's what they did. They took the JavaFX script stuff and ported that to Java. That if you buy a book about JavaFX script, you can more or less take all the examples and just write it in Java now. With the builder pattern, it looks very similar to the original JavaFX script these days. Yeah, like I said, it's not part of the Java SE distribution anymore since Java 11. And that leads to some confusion. So most of these frameworks are still in use today. And the question that I'm really often confronted with customers is JavaFX dead because it's not part of the JDK anymore? And then you have to explain it never was part of the JDK. It was just came bundled with the JDK, and it's open source for a couple of years, and it lives on OpenJFX.io. So you can go there, and as far as I know, it's now also on GitHub and not on Mercurial anymore. At least there is a mirror on GitHub, and it is easier now to for example, put some issues in there, because before that you need to be an OpenJFX committer to really open an issue and all that stuff, but they changed it. It's driven more or less by the community, which means still no image. Okay. It can run on mobile using Gluon. Does someone ever played around with Gluon here? Wrote a mobile app, one, okay. Which is kind of fun, using a Java application running on your mobile phone as a native app, which is possible. And you can run it on the web. Does someone know JPro? One, okay, it's only one. And yeah, this is still actively developed. So there are still people in Oracle developing JavaFX, and also the Gluon guys, and there are also some community members that actively develop that kind of stuff. So the question is, where does Java on desktop suck? And there are a couple of points I will show you. So first of all, there is a lack of third-party controls, at least in JavaFX. In Swing, we had a lot of stuff, and then when they came to JavaFX, it looked like people are not willing to really continue creating third-party libraries, right? So it's there have been some great libraries for Swing, but the people started converting it to JavaFX and then stopped it. And so JavaFX lags really behind if it comes to custom controls or public available libraries. Then we have missing features, like if someone ever tried the table view in JavaFX, it really sucks. It's a pain in the ass, sorry, but it is. So if you know the Swing table view, which works, not perfect, but it works, and it's very customizable, the JavaFX table view, yeah, not that easy to customize. And the problem is, if you go to a customer, they expect you to create something like an Excel sheet. In Swing you can do, it's not easy, but you can. In JavaFX, it's nearly impossible to create that with the existing table view. Then mobile. There is a support for mobile with Gluon, and it works. But even if the Gluon guys really does a great job, it's still lacking behind native apps, which is more or less the same for web apps. There's still a little difference between real native stuff and, for example, stuff that is running in JavaFX or in web on mobile devices. UI design tools. In Swing, we had different design tools that was easy to build a UI. For example, if you have to create a business UI, it's very easy to just place some text fields and all these things, connect them to the code. For example, NetBeans was awesome, right? It was, for me, the best UI editor, and it came with the IDE, so it was really great. In JavaFX, we have the scene builder, which is kind of okay, but if you work with it, sometimes you have the feeling it's not there yet, and that's the only tool that we have. So which is, yeah, it's not really nice. Oracle support, lack of Oracle support. It feels like Oracle has no interest in Java desktop technology, at least at the moment, right? Because if you take a look at what they did, then they kicked out JavaFX, so we don't need to develop it anymore. We don't need to help officially. They still do, but yeah, you get the impression, desktop doesn't seem to be the future of Java. Look and fields, yeah, I mentioned that already. In Swing, doing look and feels in Swing is not really nice. It's great if you can do, but I just know a handful of people that are really able to do nice looking look and feels in Swing. JavaFX is better, but still it's not easy. OpenGL and DirectX, no support in JavaFX. If you have an application that is based on Joggle or Java 3D or stuff like that, it doesn't work in JavaFX. There is work going on to support that, but not at the moment, which is for some companies really a drawback. So, sorry. Then fat lines tend to be heavyweight and really in terms of memory and CPU usage. So that is also not in the best way, but if you take a look at an Electron app, I mean, Who's working with Electron apps here? Someone? It's also not really small stuff that comes out in the end, right? So, and if I start, I think, I don't know what was the tool. I had a tool that was based on Electron, and when I see the memory consumption, it was in the gigabytes. I was really like, what? So why? Admin rights. Oh yeah. Unfortunately, a lot of people use Windows still, and yeah, this requires admin rights if you would like to install applications in bigger companies, which is then something that blocks companies from using this kind of stuff, because it's easier to deploy via web, right? Costs. Most JavaScript frameworks are for free. Gluon and JPro are not. So you have to pay. The reason is they spend their whole day on creating all that stuff and they don't have another job. So of course, somehow they need to be paid. So that's the reason why the stuff is not for free. Updating a desktop application, yeah, that's not really right. If you take a look at native apps, there are ways to update native desktop applications, right? But because when we're coming from the Java world, there was this thing called Java Web Start. Someone is using Java Web Start still here in the audience? One, okay. There is something going on from a company called Open Web Start, where we continue supporting it. So we picked up the old stuff and developed it further. So there will be support for Open Web Start or for Web Start in the future. But there are installers, they also handle updates and all these things. So it is possible, but you get the impression updating a Java desktop application is really hard. But it's in reality, it's not really. Yeah, deployment, okay, I don't have to talk about that. Deploying native apps on desktop machines is not easy in big companies. It's easier if you use it really on the web. It's just press F5 and then everything's updated. With a desktop application, it's more hassle to update. So there is something that really sucks. Yeah, and in the end, there's really a lack of UI developers in the Java environment. So if you are looking for front-end developers, you mainly get JavaScript guys. But it's hard to find people that are able to do Java desktop apps, really good-looking stuff. And this is something where it really sucks, right? It's easy to find some good web developers, but desktop, unfortunately not. Okay, enough from the bad parts. There are also some good parts in Java on the desktop. First of all, it's one platform. And if you work, I worked in an environment in Singapore where we have a web application mixed with a desktop application. That was terrible. And then a server part and everything was different. But works together, and it was not really that easy. So it runs on Windows, Mac, Linux, Android, embedded, and even web. I don't say this is for everything, but it's not that bad, and you have to keep that in mind that it's one platform. Then it just works, because most of the stuff just comes with the JDK. Even with JavaFX, there comes a lot of controls. You can build business application with the standard framework. That's no problem. Right, so which is a big benefit. In the web, you have to decide. You go with JavaScript or whatever, React, I don't know, you name it. Then you have to decide the framework. Then you have to decide which version of the framework. And then you have to either stick with that or you have to update all the time. With the Java stuff, it's a little bit different. Well, I said it's hard to do look and feels. Nevertheless, it's easy to style stuff for customers. Like, for example, you have a customer, we have that problem quite often, and then they come up with, oh, we need a new application, and this is OCI. Can we make it look like this? Yeah, you can, very easy. Because in JavaFX we have CSS, which is, it's based on CSS 2.1, so it's not CSS 3, and it has some prefixes for all the stuff like, it's not minus background, it's minus fx, minus background. If you are a web developer, then that sucks. But if you come from the Java side, then this is really powerful because you can use, they did that to avoid problems with web stuff, because if it would have been the same name, then people would mix it up and then will end up in issue hell. So that's the reason why they decided to prefix everything with minus fx minus, which is related to JavaFX. And so you can really style, the whole styling of the components in JavaFX is based on CSS. It's one style sheet, you can just take that and override different styles, and so you can style your whole application by using CSS. Then we have the possibility of customized windows. I mean, I know it's not the big use case, but that is different from browser-based stuff because you don't have the browser as a runtime environment, but you can just create windows without any frame if you like. And in fact, we do that at the moment for customer. So it's nice to have that sometimes. You can really do complex applications. So handling large data for visualization stuff is, their desktop is really not that bad. It's quite good there at that point. And we will see some examples later on where you see that really companies that are working in this visualization area often use Java desktop applications to do that because web cannot really do all the stuff they need at the moment. It might come in the future, but at the moment Java has some advantages there. And because I said it's on the same platform, means we can use the same tools, which is for me the biggest benefit. I can use the same IDE, same test frameworks on the server, on the client side. Even if I do a mobile app, can I test it on the desktop? And I can use the same libraries. I can share the code between desktop and server stuff, which is really convenient. Not always, but it can be really helpful, and you don't need a very specific team to do that because you just need Java developers to do that. Yeah, reuse code. Yeah, that's exactly what I said. So you use the same libraries on server and client side, which is a big benefit. So you don't have to change. You can even test and run everything from one IDE on your machine. Sorry. Concurrency, yeah, Java was built with that in mind. So it's multi-threading and concurrency are well supported in the Java platform. And for years it's running and working. So this is, I don't want to say it's bulletproof, but it works. We have the possibility to do native access. Does someone ever did JNI and JNA here? Yeah, a few. It works. If you know what you do and you're comfortable with C and that, then you can do some interesting stuff. For the normal developer, it's mainly not that easy. Hopefully, Project Panama will fix that in the future because that is about native access. We have drag and drop between Windows, desktop, file system. You can just drag stuff around. That's no problem. Within an app, from the app to the desktop, from the desktop to the app, and all these things, that works. And of course, network programming, Java supports all the protocols and stuff. Java 11 comes with an HTTP client. And so you don't need Apache or anything else anymore. You can just use plain Java to do that, which is nice. Bluetooth, okay. USB, you can do, but I tried that. It's not that convenient, but it works. You can use it. So internationalization is also no problem in Java. So we use that a lot for customers in different countries. And to be honest, I don't know how it's working with web applications. I never did, but I think it shouldn't also be a big problem to do it there. But in a Java application, that's easy. We just build our own framework to do that. So it's no problem. Offline capability, of course, desktop applications always can run offline, except you have to trigger web services a lot. But the application itself can run also a web application as long as it doesn't really update something from the web, can run in the browser, of course. It's hardware accelerated, so which is nice if you do research apps or science apps where, for example, NASA uses it and they decided to go with JavaFX instead of a web application because they had to visualization of trajectories of satellites going around in the solar system. And they have to do a lot of visual stuff, 3D, and therefore it works quite well in JavaFX. It runs on mobile. I told that already. With Gluon, you can run JavaFX applications on mobile, desktop, and also on embedded. That's also possible, no problem here. And it runs on the web using JPro. And that's an interesting approach, and I will show you a little demo for that after that. All that slides here. Java has a stable API, of course. I mean, you can run code for years and it didn't really change. There's really rare that stuff is deprecated or doesn't work anymore. And if then the IDE support is so well that it tells you, oh, you have to change it to this. And sometimes you can just click change to code style, whatever, Java 8, and then it will reformat and then it works again. So that's really not a big deal in Java. And a big benefit is that the application lifecycle, because of the stable APIs, is completely different from web applications because it looks more like this. If you have a web frameworks, then usually the lifecycle is like this, right? So you start one, 2 years later, the next one, the next one. That's how it works at the moment. It will stabilize in the future, I'm pretty sure, but at the moment it feels like that. Where you have a Java application, then it looks like this. Okay, you started once and then it can run for 10 years, 15 years. We have customers, they use stuff that we didn't even know that it's still in use. And they use it and they are fine with it. So that's just, if you have a stable API and don't change the framework all the time, then you can do stuff like this. And I found it interesting when I talked to a customer and they also built a web application for themselves and they said, yeah, well, we change the whole application every 2 years. I said, what do you mean the whole? Yeah, we rewrite from scratch every 2 years, the complete application. That's how we work. And I thought, okay, this couldn't be really a good idea, but he was totally fine with that and said, we plan for that and that's how we work. Well, yeah, maybe that's also an approach, but I prefer doing a little bit different things, not doing every 2 years everything new. So typical environments for Java Desktop is then, for example, insurance companies, it's banks, it's the industry in general, producing industry, scientific institutes, military is using it, trading companies, aviation, space and defense, medical stuff, and automotive. For example, a couple of years ago at Java 1, where it was still Java 1, not Code 1, there was a guy and he pinged me and said, Gerrit, I have a session later on and you might want to come because I show some really interesting stuff. And I was like, who's that guy? Ah, I follow you on Twitter for years and I'm coming from Volkswagen. So, okay, I will join the session. And then he showed off a JavaFX-based media center that they are playing with in Volkswagen, which was really awesome. And nobody knew that they're working on that. And then he told me that on all Volkswagen stuff, and not only Volkswagen, means Audi, Porsche, I think Skoda and Seat, and what else? They have more, I don't know. All these things, all the media stuff in the cars runs on Java. Nobody knows that, but it's true. So they just don't use Swing at the front end. They wrote their own layer for the UI, and it's Java 1.4, but all the media stuff in the cars from Volkswagen company is running on Java. I didn't know that. And that's the big problem here. Because people don't talk about it, doesn't mean it's dead, right? So these big companies mainly use Java Desktop internally. So we have a lot of projects running only Java Desktop stuff. And these companies never talk about that. For example, Zeiss, right? They do microscopes. For years, they base parts of their stuff on JavaFX. And at one meeting I had with some people, one of the guys sitting in the audience was coding all the time, and he was really good in that stuff that I saw. And I asked him where he know all that from, and he said, well, we work with that. We use it in our products. I said, so what is the company? Zeiss. I was like, oh, Zeiss, wow. And he said, yeah. And I asked him, why don't you talk about that? And he said, well, you know, for us, it doesn't have a benefit to make some noise about the UI toolkit because the customers don't care what it is. And for us, it's just, now we use JavaFX, maybe it's something else in the future. And so this happens with a lot of stuff. The military, I met some people from the military in the US, and they also work, a lot of JavaFX stuff is working there internally, but nobody knows. They will never talk about that. Same goes for medical, space and defense. I know Airbus is working with JavaFX and others. So here are some examples who is using not only JavaFX, but also Swing, right? It's, of course, IntelliJ. It's Java on desktop in general. And you see there are also some big players in there, like IBM, Audi, Airbus, BMW, Emirates Airlines. And all these companies use Java desktop technologies internally. And there are more. This is not all. That's just the stuff that I know. Like banks, the big UBS bank, some institutes. So it's really some big companies working with Java on desktop here, and many more, like I said. So Java on desktop is dead. That's what everybody says for years, but it seems it's not dead yet, right? So there's still in use, and just because nobody's talking about it doesn't mean it's not there. Unfortunately, it's hard to convince people that it's still available. So the problem is, if it's not dead, why is it not taken into account then? What is the problem here? Why don't people really use it or start using it? Well, that's what I call hype-driven development. Because I found that in many companies, when we go there and we show some stuff and they have an offer and we try to make a demo, then it's going like this. First of all, they make a technology decision. We use whatever fancy web framework is the latest one. That's given. We use that. That's the first decision they take. Second one, okay, let's solve the problem with this framework. That's how they work. Sometimes even they plan to use stuff that's not even released yet. Oh, it will come in the end of the year, but we still use it. We use the beta version for development. Okay, you can do that. And that's what I see. It's not one case. I had that at least 5 times this year where we come to companies and they work like this, which is really crazy because I thought it should be more requirements-driven development, right? So that means, first of all, you try to understand the problem. Then you make the technology decision. Means if it's a project that's worth going on the web, then use web technology. If it makes sense to use it with a desktop technology, then use desktop, why not? But this, people don't take it into account because it's just given that they say, oh, there's this latest Angular version, we have to use it. Nobody asks why. It's just because we decided that. And yeah, I think this is not correct. And then in the end, you have to solve the problem again. But if you use the right technology to solve the problem, it might save a lot of time and money. Well, what we do is we use some kind, we call it a questionnaire matrix. Means you have something like that, and you have some points that might be important for you. And then you have some columns like very important, important, not that important, unimportant. And then you just mark it and you give points in the end. So for example, license cost is important, and for you it's really like, yeah, it's for web it's 4, and desktop you have to pay -2, right? So you have to be honest with these questions, and in the end you will get some result which tells you which technology makes more sense. This is just an example, so you don't have to take that really as a good one, but you can do stuff like that. And then you just count the numbers, and in the end it will give you some direction to think about if you should use web or desktop, right? Which is, I mean, I don't know how it works in your companies or where you work in projects, but I had the experience that people never talk about the UI technology. It's more or less given that's a web application always. Nevertheless, if it makes sense or not, they don't discuss that. They do it and then try to work around every problem they face, which is, yeah, I don't understand that. So let me give you some examples for desktop applications, for example. So this is an application from Zeiss, which is the frame is a JavaFX application. The center one, this is an eyeball, I think, is a Swing part. So they mix that because Swing has still, I told you, Swing has access to OpenGL and also some image stuff is image libraries that are really well designed, are available for Swing but not for JavaFX. So they just decided to mix it because it's possible. You can mix Swing inside JavaFX and the way around. You can build a Swing application with JavaFX inside. So that's what they do. That's what they sell to customers. Then this is a Mint. Yeah, this is for training pilots. It's a company. They do this kind of software. Don't ask me what it exactly does, but yeah, it's a. You see this. You can also do that with a web application. This is not now not only applications that are you can only do in desktop, right? This is just applications that are out in the field that we found, and that we are allowed to show, which is also a problem because some customers like military, Airbus, we are not allowed to do that. I can say they work on that, but I can't show any slides or stuff. This is from NASA. This is the Deep Space Trajectory Explorer, where this is just one image. This application was a couple of times shown at Java 1 and Code 1 because it's really impressive what they can do there. And they really use that to calculate trajectories around planets for missions for NASA and all these. So, I talked to the guy who did it, why he chose JavaFX and not a web application. And he told me he started with web, but it didn't work out. So he moved to, because the amount of data they have to do was just too big. It was not possible to do it in the browser. This is now a couple of years ago. Maybe these days it's possible, but that's a good example where they make the decision and decided to go with a desktop application. This is something we did for Conchip, which is a company in Italy, where they plan containers on container vessels, and you can do a lot of stuff here, like all these different colors standing for different kinds of containers, and then you can place them on the ship, below deck, above deck. You can have a scan view and all these things. You can define the whole ship there. This is from Airbus, where they use, this is open source. So this is for showing 3D simulated wings of airplanes. They use the Java desktop application to do that. I bet they could probably do some WebGL stuff, but they decided to go with a desktop app. I don't know why, but yeah, this is the whole thing is open source, and it's called Equinox. If you use on GitHub, search on GitHub, you will find that. And things like these buttons on the below bar there, things like that, you can just style. This is CSS. You can just use different CSS style, and it looks totally different, like you know it from the web. Then there is a CRM. This is coming from Switzerland, where a company developed that, and it's in use. And here we have the GSI. It's a heavy ion research lab in Germany. They also go with the JavaFX application for the analysis of the accelerated ion beam, and then the results from that. So, oh yeah, that was my own stuff. That was used at the Code 1. Oracle built this 1060 pi cluster, and then they monitored it using my library. When I heard that, I was a little bit surprised if that really works out, because I created that library to create dashboards, but not for 1060 tiles, and it worked. So it's okay, it's nice. And here are some examples for mobile. This is now JavaFX running on mobile devices. I think this is an Android devices here. And yeah, the Vox days, Devox, also the application from Devox to to have the catalog and all that is a JavaFX application. And you can download it from the App Store. So it's a native app that you can download from there. Here you see there is also support for 3D stuff. We have a map in WebView, in the web mobile version. And then on the right side, again, this is my library. I just show that because I have a demo with that one for the web version then. And the interesting part is if you create a mobile app, I don't say this is for everyone, but if you're a small company and you would like to create from your application a mobile application, then JavaFX on mobile is fine. Or for example, where we used it with a big bank, they built a desktop application that I'm not allowed to show, but then they decided the management needs a dashboard, just for the management. And for this part, they would like to do a web application. So I told them why they don't just create a mobile app just with the dashboard. So because then they can use the same code on the desktop app and also in the mobile app, and that's what they did. So you can do that for small parts. There's also this game, which is 2048FX, which you can find in the App Store, in the Google Play Store. There it is, and you can install it on your Android phone. And surprisingly, sometimes the JavaFX apps are faster than a bad programmed native app on Android. So it's really interesting. So they do a good job at Gluon to make that as fast as possible. So the requirements for the Gluon stuff is you download the IDE plugin and you say new Gluon project, and then you can create an application with desktop, iOS, Android, and embedded parts. Right? Yeah, exactly like this. That's what they do. You have the main folder, which contains all the code that is shared over all platforms, and then you can platform-specific code, like the mobile app, looks different than the desktop app, right? And the mobile app has the orientation like that, where the desktop has the orientation like this. So means if you have, for example, material design, this is made for mobile apps, not for desktop apps. Never do that. I did that at one customer because they decided to go with a material design application on the desktop. The problem is if you have lots of forms with text fields, then material design has this behavior that you have a text field. As soon as you click on it, then the label moves up. And if you have a hint text, then it goes below the text field. That means you need a lot of space in the vertical area. And on the desktop, you don't have that space. You have space in the horizontal. But on the mobile phone, you have endless scrolling. There is no problem to have the vertical space, right? So there you can see that material design was built with mobile in mind. And here you can then, for example, create your desktop application. The UI it could just be the UI layer, and for the Android could be different, and iOS could be different style. If you would like to have a specific iOS-looking application, you can design that in the iOS folder, and then afterward, if you build it, it will take the code from these folders. Then we have web. This is again, that's why I show it. This is again just a demo of my dashboard library running in the browser, and I will show you the same thing runs as a desktop application. You can run it on a mobile device. There's another one that's a company in Great Britain. They are running a JavaFX in the browser in an application. A friend of mine is working on that project. So that looks like a web app, more or less, but this is JavaFX. Right? And it's for energy management in general. So the requirements for JPro, it's interesting because the only thing you need really is you need to add the dependency on this JPro plugin or Maven, Gradle or Maven, depends what you use. And then you can run it on the server. You start the application on the server and then you can open it in the browser. That's what they do. The idea behind it is that the application logic runs on the server where the UI code is transferred to SVG and is rendered in the browser. So they split the rendering from the JavaFX platform and put the rendering in SVG in the browser, which means it's hardware accelerated, so it's not that slow. Right? The problems that they have is session handling and that kind of stuff. But with the containers, you can also spin up this application in different containers, so that's for them also no problem anymore. Let me show you a little demo with this stuff. First of all, I start my dashboard application, which is a native application on my desktop. And there it goes. It's a little bit slow network. There should come, there's some data. So as you can see, this comes with a native frame. This is really a native application that I can start from my desktop here. So now, let me start. This is the wrong project. This one. Start JPro on my local machine, so I just start the server on my machine now. Okay, takes some seconds to start up, so here we go. Then I go to the browser and call localhost. Here we go. Start it, now it should load, there it is. And you see the same thing. And it's, here I can, for example, that's because the network is not the fastest one here. But here it's the same application, and if I go in the web and press, for example, this one, then you see in the desktop application it's the same. If I switch it here, then it should, oh, it doesn't. Why doesn't it? Oh, it's just one direction. Interesting. That was not planned. Okay, usually that should work in both directions. And it does, yeah. So I was surprised. It might be the network. It's a little bit slow. So what it does, it really, like I said, it's the same code. The server splits up the rendering and puts it in SVG and puts it in a browser. And there you can run the same application with resizing and all these things. Depends on the speed. But yeah, you can build desktop applications running in the browser, right? And it's Java. It's the same stuff. And it's really, I'm using this project to build it. I built either the native version or I just run it on my server. And in the end, for example, if I use my mobile phone, I can even run it on here. It takes, yeah, there it is. So it's because that's running in the browser. This is just fast. Even if I change the orientation, it will switch orientation and all that. So you can build a desktop application that will be rendered in the browser then, right? Which is kind of nice, I think. So in the end, means if you take it into account, Java on desktop, it won't die, hopefully. So that's it from my point of view. I thought it's worth talking about that topic. If you have any questions, we still have 6 minutes left. So any questions in the audience? I know there is Duke script. Someone pointed me to that. I should mention it. I just mentioned the stuff that comes with the JDK, or that's at least was part of the JDK or came once with the JDK. There are other frameworks that you can use to build desktop applications in Java, like Duke script, for example. Does someone know Duke script here? Of course, you know. Anybody else? So you should talk to Jaroslav. He's the one. Just come on, raise your hand. Talk to this guy, because it's really interesting stuff. But it was not really part of this presentation. And of course, there are other stuff like, I don't mention yet now, Kotlin, which is still using Swing on the end. So, but you can use whatever language runs on the JVM and use the UI frameworks for that, which is also an advantage, right? So you can run Kotlin and run a JavaFX application, or you can run Scala and create a JavaFX application, which is no problem, right? So, any questions? If not, thanks for attending.